Yeah, so unless there's anything else that people urgently need to get out of the way, I think we can jump into our first presentation from Henning, who has been the MoveIt architect. So he's been with PickNik for a number of years and has really taken the lead on first creating MoveIt 2, or basically getting MoveIt running on ROS 2, and which is now a feature equivalent of MoveIt 1, and actually has gathered a number of things that don't exist in MoveIt 1 just yet. He'll tell you more about all of that now. Henning?
All right, thank you, Mark. Yeah, I will talk a little bit about like what happened since last year. What were the main highlights in 2021, and how have we progressed, and what kind of things we are focusing on right now, and what you can expect in the near future. So I will cover rolling galactic support, what was supported last year, hardware support, and our feature highlights, and then our current roadmap and how we want to grow the community in the future. So I think biggest change last year is that MoveIt 2 finally got feature complete, and with that we had new releases on new distros. So before that we only had Foxy support, but the new main branch, which is the corresponds to the master branch of MoveIt 1, gained support for rolling and for galactic. Rolling is like the name says, rolling release. Rolling will be there forever, and new distros will be branched off of rolling. So this will be always supported by main. And galactic is the last distro release that by now already has a stable galactic branch, but main still supports galactic as well. As we are approaching the Humble release in May, we will, of course, add Humble support to main, but then galactic will be dropped because it's probably not possible to keep compatibility with it. So the things that were reported in last year were MoveIt Task Constructor. I think this was probably the biggest effort. It's a huge code base, and but now everything is working in MoveIt 2, and we are using it in a number of projects already. So feel free to test it and see how it works for you. We try to keep it in sync with the ROS 1 versions, so of course, so there can always be some delay with features getting synced. But we really try to keep up to speed. Also, MoveIt Visual Tools is available, so you can finally play around with colorful things in Arvis. And there are 2 new planners which are reported from MoveIt 1: Field Planner, Industrial Motion Planner, and Chomp. So yeah, those are fully functional. Feel free to use them. Yeah, a year ago, actually, like we heard a lot of voices that said, well, everything is nice and fine, like it looks good on ROS 2, but is it actually working on hardware? And at that point, actually, a lot of hardware that were supported in MoveIt 1 was not really running in MoveIt 2 because we didn't have any drivers. So we worked together with Universal Robots to implement the ROS 2 driver, and that's, I guess, one of the most used robots out there in the ROS space. So we're happy that this is fully functional by now and supports MoveIt. Also in collaboration with another hardware vendor, Hello Robot, we implemented full support for their mobile base. This doesn't even only cover MoveIt configs, URDFs, but also controllers and simulation. And one nice feature that we also got out of it is that MoveIt actually has support for planar joints now. So you can use a new joint type, which supports stiff drive and holonomic drives, so that you can model any kind of mobile base with MoveIt and actually plan with it. So if you want to know how that works, there is a tutorial for that. And there's also a really nice demo that we prepared for the Roswell 2021 workshop that really covers how to set up a mobile manipulator and how to use it for planning and actually how to run things in a simulation as well. So this demo actually covers MTC, like you can plan your navigation basically with MTC. Of course, execution is a different thing. So if you want to execute that plan in the real world, that still needs some additional tooling, but at least you can see that it works and the concept works, and also you can execute it in simulation. So if you're interested or working on similar problems, you can check out the link below here, and you can run all of the things that we presented in the workshop in a Docker container, and no need to set anything up. Let us know what you think. Another, I think, major change was that MoveIt gained support for running multiple planners at the same time. So before that, you were always stuck to one kind of planner, or one planner plugin instance. So if you picked OMPL for your runtime, you could not switch to Stomp or Chomp or Pills at the same time. This is not possible. We solved that by adding MoveIt CPP, which is the C++ interface that in MoveIt. We integrated MoveIt CPP into MoveGroup, and MoveIt CPP already supported multiple planners. So we just added the interfaces to load and to select the planning pipeline that you want to use. That feature is available in the ROS 1 and ROS 2 versions of MoveIt, and I think it's a really nice addition. Another change that only affects the MoveIt 2 version is that we simplified how launching works for us a lot. Since the start, we were dealing with like huge launch files on that side. This is still a good case, I guess. We have launch files that root over like 200 lines or so, but the left side only shows launching the MoveGroup node. And if you compare to ROS 1 launch files, it's just way too much boilerplate stuff for loading a bunch of config files. And there's a new library now that's called MoveIt config utils that provides a builder function for generating those config files. And all you need to do is we just call your the MoveIt configs builder with your MoveIt config package, and it will load all of the default config files for you. And you can just just move them into the parameters section in your node, and that works. So launch files got way easier with this. Another major feature is the hybrid planning pipeline, which finally got merged into the main branch and also Galactic branch. This planning architecture allows planning and execution of trajectories that have some dynamic elements to them, that allow replanning, that allow adapting to like immediate changes in the scene or in your planning task. It's fundamentally different from how SensePlan Act worked with the old planning pipeline. But it's also still very experimental, very early, but we have been investigating use cases and best practices since we've been working on that. The idea behind hyperplanning is that you basically share or split your planning problem into two chunks. You have a global planner that basically does the same thing as the old planning pipeline. It reads the planning scene and computes a free motion plan, for instance, and that motion plan doesn't really change at first. And the local planner is like a controller that follows the trajectory that the global planner computed, but it also allows solving certain kind of local constraints. Those constraints can be avoiding collisions locally, like modifying the trajectory online while keeping away from objects. This can be any kind of sensor input that's getting processed here. It can also just reparameterize the trajectory online. This really depends on your application and needs to be, it still needs to be implemented based on what you want to do with it. The hyperplanning pipeline is not intended to be a solution for everything. It doesn't provide the implementations yet. It's an architecture that allows you to do these kinds of dynamic planning problems. One example that we've been working with Fraunhofer is a welding application. Christian and Gauthier from Fraunhofer, they have been working on a welding application already in Rust 1. They were using MoveIt 1, and our plan was to realize this application with hyperplanning. And the reason is that the original application used two very similar motions, and the first motion, basically two phases. The first phase was that, like you see on the right side, the robot here, the welding seam of the object is known, but the exact waypoints might not be known yet because the positioning of the object is not like 100% accurate. The robot has a laser scanner that allows scanning this welding seam and generating waypoints. So the first phase is really running the laser scanner along the welding seam and trying to collect the actual waypoints that we use for the welding trajectory. And the second phase, of course, is then the execution of the actual welding path. So the goal with hyperplanning is to unify both phases and do the scanning and the welding at the same time. So that means you need to run it, like plan the trajectory and run it while adapting to the sensor input. The links on the bottom here, you can see the GitHub project and their project page from Fraunhofer. So yeah, as I said, we try to realize that with hyperplanning, and that means that we specified the global and local planning tasks separately. And the global planning task is basically really just computing the welding path already for the known workpiece. This needs to be done because we already want to be able to somewhat execute the welding motion. And the local planner is tasked with adapting to the sensor input and executing the preliminary welding motion. So on the bottom, you see the waypoints that get recorded, and those waypoints need to be processed online for adapting the tooltip, depending on what kind of sensor input we have. If you want to see this in action, there's a lightning talk prepared by Gauthier and Christian, and they show you how the welding motion actually looks like by now. This project is still work in progress. It's not like fully solved yet, but the hyperplanning architecture is functional, and we are still working on bridging certain Rust 1 and Rust 2 components. All right. Next news is that we've spent a lot of effort in improving the MoveIt 2 documentation and tutorials. So yeah, with MoveIt 2, a lot of the old tutorials that already existed needed to be updated. They were somewhat either obsolete or just not up to date anymore. Some of the concepts changed, some of the interfaces changed. So we started updating those, and we figured that somehow a lot of the tutorials weren't really consistent. So we thought it would make sense to rethink how we present the tutorials and try to come up with a better structure for them and try to guide the reader better in order to help them learn more about MoveIt and also to find what they're actually looking for. So yeah, the new tutorial pages now have different types of content: tutorials, examples, concepts, and how-tos. And those types of contents are now basically allowing you to directly find what you're looking for. If you're looking for like learning material, you would go for a tutorial, for instance, because the tutorial is a step-by-step guide for whatever you want to learn. There are not a lot of tutorials yet, but we are working on adding to them. The examples are basically just is most of the old content. If you look for like some inspiration or some ideas on how to use things, the examples are the way to go. Then concept pages are basically documentation of architecture and design patterns. So you can't reproduce anything here, but you will learn more about the backend, about the details of MoveIt. And then how-to guides are not really learning material. They show you how to solve specific problems. So how to set things up, how to debug motion planning issues. So those are really intended to be used by developers who are blocked, for instance, and who want to solve the problems. Yeah, also these tutorials provide multi-version support. We will always keep the latest stable branch up to date, and main might be a bit newer, but might not apply to the latest stable branches. So yeah, we would always recommend to use the latest stable distro. And also we integrated our API documentation here, so you can directly find all the classes that MoveIt provides. All right, and last kind of news, we started making our planning and issue management more transparent, and remove all of the maintenance and development tasks that we planned internally at PickNik. We moved that onto GitHub and started also integrating all of the issues, bug reports that we get on GitHub into our planning schedule, basically. And for that, we use Zenup. And Zenup is a tool that integrates really well with GitHub because it just is based on native GitHub issues. And you can link everything in one place. You can play with the pull requests. You can build your roadmap, like your feature roadmap with that. You can plan development sprints that we do at PickNik. And it really allows us to work closely with our work items. And yeah, and also it's easier to collaborate with the community as well. Yeah, speaking of roadmaps, so on Zenup, you can directly follow what we're working on. And this is basically our immediate roadmap. The items that you see in the roadmap panel are really the epics that we have laid out over the next weeks and months. And those are the things that we are focusing on right now. So you see here, there's still, like up here, is the last release for rolling. We have still some efforts about documentation. The Dockathon was something that we did in January. There's still some open issues that need to be closed. We're working on Jammy support right now because rolling switched to Ubuntu Jammy, and we need to switch the main branch as well, also in preparation for the Humble release. We expect the Humble release to be in May, and we still try to squeeze more features into this Humble release. We already have improvements for MoveIt Controller Manager, better tutorials. The Hyperplanning feature was merged in preparation of this. We are working on finalizing the MoveIt Setup Assistant part, and there are still some efforts to clean up some of the outdated code and unused code to make it easier to disentangle the code base and to make bigger changes in the future. Also, there are some efforts about modernizing the code base and future milestones like implementing best practices for parameter loading or adding ability to attach, detach, and affect the links. I will briefly cover some of those epics. So for MSA, for who doesn't know what MSA is, so the MoveIt Setup Assistant really allows you to build your MoveIt configuration given your robot model, basically your URDF description, and to create all the configuration files and launch files that you need for running your robot application, basically. And that already, I mean, it exists in Rust 1, and we ported part of it to Rust 2, but a lot of the things changed with Rust 2. So it needed kind of a redesign, and we wanted to change a couple things anyway. So our goal with this migration right now is to generate the new kind of config and launch files like with Rust 1. So the first pattern will be very, very similar. But it also will provide a plugin architecture for custom widgets. So if you have any custom capabilities, any custom tools with your application, and you want to be able to generate the config files, the plugin architecture will allow you to do that. Future work with MSA is still making configs and launch files simpler. Like for instance, we want to be able to build configs based on each other or inheriting from other config files. Imagine you have like a basic UR MoveIt config, and you just want to put that UR on a table with some other tweaks. You might be able to inherit from that basic UR package and just add your own flavor to it, basically. Yeah, we're thinking about things like this. And then we want to be able to generate and validate configs from the node parameters directly instead of copying templates. This is another, this is dependent on another effort that is going on, and that is, the implementing best practices for parameter loading. So this is more like a long-term effort. There's still a lot to investigate, but yeah, this is a related issue that goes hand in hand. Also, you see the epics here for modernizing and modernizing the code base and making it leaner. This has been planned for longer to make to improve the code base overall, the code quality, and those epics are really focused on improving consistency and reducing bad smells in the code base. Yeah, what else? We have been investigating tool changing. This is a use case that has been requested by many different sites. We have an epic to get that done, and the desired solution would be to make the robot model like dynamic to allow changing it at runtime for switching tools. That's like the ideal solution. We already have another tool changing move group capability that also works but doesn't change the robot model. So this doesn't really solve the epic, but if you're interested in tool changing, you can check out the GitHub repository here, PickNik Robotics tool changing, And there you have a solution that is really based on enabling or disabling predefined end effectors for planning and for collision checking. So until we have some dynamic robot model, this is probably the way to go. Also, we have a related roadmap item that really is about adding support for dynamic robot models or for dynamic scenes, like scene graph support. This is a really interesting topic that has been discussed for a really long time, and we are really interested in adding that capability to MoveIt. So if you're interested or maybe even working with something like this, please let us know, and we are happy to discuss these kind of problems. So our last but really most important issue is probably growing the community. We're really looking for more maintainers and contributors besides PickNik. And we are always interested in collaborating with everyone who is motivated to get features added to MoveIt and to investigate other use cases, new use cases that move it forward. And what we've been doing is to encourage more coordinated team efforts across different companies or different people. We also engaging more and more contributors by letting them support and learn from more experienced maintainers. We try to not let everyone work alone on their end, especially if they are just starting out. We are again participating in the Google Summer of Code program, working on better design patterns, more consistent and intuitive design patterns and documentation to shorten the learning curve, and organizing community events like this one. And also, who is interested in getting started with new contributions in MoveIt 2, we have a weekly developer stand-up meeting every Tuesday, 3 p.m. UTC. And let us know if you want to join, if you want to see how we work, or if you just want to get started in contributing or reviewing. We would be really happy to see you there. All right, I think my time is about over. Thank you for attention.
Yeah, we're magically back on track. I hope we can answer a few quick questions that popped up in the chat. The first one is from Moshe Wisnitzer. He's asking, is there a future plan for the local planner to listen to sensor feedback like FTS? This is in the context of hybrid planning.
Yes. So we for instance, the Hyperplanning demo, the welding demo, is intended to use sensor feedback in the local planner. So this kind of use case is already intended. The question is what kind of examples or what kind of default implementations we would add. And there it's really hard to tell what default implementation would be most useful for everyone. We would definitely provide more examples that you could pick up and modify for whatever kind of sensor input and whatever kind of constraints you want to use.
Next question from Solomon Wisnitzer. Are there plans to port over the MoveIt Commander API from ROS 1 to ROS 2?
That's a tough one. So currently, not really. We are definitely interested in enabling the PI bindings, so the Python bindings that are proposed for MoveIt 1 right now. The issue is that we have is that we don't use it at all. So if there's someone interested in using it, then we would definitely support them getting it enabled. But for us, it's really not the highest priority at this point, fortunately.
Somebody posted a link to their personal repository on creating Python bindings for MoveIt 2 through a message interface. Andre Ortela. Yeah, this is definitely something that's of interest. We recognize a lot of people like Python and like to program in Python. But so yeah, maybe a topic for discussion during the break or later on how we can best get this fully supported and integrated with MoveIt. I think, oh, right, there's one more question, a quick question from Gauthier Hens at Fraunhofer. Did you consider using MTC and attach collision objects for tool changing? Well, I guess Michael already answered this, that it's actually not that easy because end effectors can be articulated, and that's collision objects cannot be articulated. So
yeah, that's the main problem.